Right, we're recording this for the sick and shut-in among us. We all hope y'all feel better soon. All right, so starting a new chapter, chapter 7. We're moving away from quadrilaterals. I'm sure everyone's sad to leave them behind. We're going to work on polygons for a little bit, those with, 5 and 6 or more sides, for just like half a section actually, and then we're back to everyone's favorite triangles. But today is actually a review of a concept in Algebra 1, but I just want to make sure you really have it before we move on. So, first thing we're going to talk about is 7.1 is called using proportions. Okay. So we got some vocabulary in here. The first one is ratio. And a ratio is just a quotient. Now what does quotient mean? Divide, right? So it's a quotient relating to values. Okay. So, if you were to drive 60 miles in 1 hour, okay, what would a ratio be to discuss your speed? It would be 60 miles divided by 1 hour. 60 divided by 1 is 60, and miles divided by hour is miles per hour, okay? And that'd be your answer. Now, miles is a unit of measurement that measures what? What is miles a measurement of? Distance. Hours is a measurement of what? Time. Okay? Distance and time are not the same thing, right? So, there would be no way to reduce miles over hours. So it's just left as miles per hour. Now, some people say some really bad ways to define ratio is they'll say quotient relating to equal values. Well, they're not equal. 60 miles does not equal 1 hour. 60 miles is a distance and 1 hour is time, right? So there's no way that could be equal. That's like saying Alabama equals 14. Like, that doesn't mean any, they're two totally different things. They can't be equal, but they're equivalent. They go together. 60 miles is equivalent to 1 hour in this scenario, right? So what would 120 miles be equivalent to? 2 hours, okay? They're not equal, because 120 miles does not equal 2 hours, but according to this ratio, they're equivalent. Now, if the top and the bottom are measuring the same thing, so like if the top had been in seconds and the bottom was in hours, those are both measuring time, right? If that's the case, you have to change it so that they're both the same unit and cancel the units. Here we couldn't do that. We couldn't change miles and hours to be the same unit so that they cancel. But in this first example, that is possible. Okay? So example 1. And I'm actually just working out the examples from your textbook, but I'd rather you not look at them because they have the answers on there. So I want you to look here, even if you've got your book with you. So, number 1 says, special effects in movies are often created using miniature models to film. So they'll, make small scale models and they'll film that, and on the screen it looks like the real thing. So, in a recent movie, a model Jeep was 22 inches long. The actual Jeep it was modeling was 14 2/3 feet long. What is the ratio of the length of the model to the length of the actual Jeep? Okay, so ratio means it's going to be division. What is the length of the model? The model of it. 22 inches over, what's the length of the Jeep? 14 2/3 feet. Now, if this were up here, all you would have to do is reduce the fraction. Okay? And when you have a fraction that has more than one fraction bar, that's called a compound fraction. And the first thing you need to do to reduce it is to get rid of that. So we'd multiply top and bottom by 3 to get rid of that fraction on the bottom. But inches measures what? Distance. Feet measures what? Distance. So they measure the same thing, so we have to change them to be the same unit. And it's usually easier to change them to be the smaller unit. Okay? So we want both of these to be in inches. So 22 inches, we leave in inches. But on the bottom, we need to change 14 2/3 feet to be inches. Okay? Now I'm going to show you a way to convert that's probably different than what you've learned before. But I want you to learn this way because you have to convert this way in chemistry. So it's coming. All right? This is a huge part of what you have to do in chemistry. Think back to the properties we learned in algebra. And is there a number you can multiply a number by that does not change the value of the number? 1. That was called the multiplicative identity. You remember back. So if we want to convert 14 2/3 feet, when we convert, we want it to stay the same value, right? We don't want it to be longer than 14 2/3 feet. We don't want it to be shorter. We want it to be the same value. We just want to know how many inches that is. So if we don't want to change the value, we need to multiply it by something that equals 1. Okay? Well, how can you have a fraction that equals 1? What has to be true about the fraction if it equals 1? What divided by what would equal 1? Anything divided by itself. So if the top and the bottom of the fraction are equal, then that fraction equals 1, right? So we need to multiply this by a fraction where the top and the bottom are equal. Well, what do we know about feet and inches? How many feet equals how many inches? 1 foot equals 12 inches. So we could do 12 inches over 1 foot. Is that a fraction that equals 1? Yes, because the top and the bottom are equal. And if the top and the bottom are equal, then it equals 1. We could also do 1 foot over 12 inches, right? Those are 2 ways to write a fraction that equals 1. Now, if we want to multiply this by this needs to be a fraction too, so let's put it over 1. If we're wanting to get rid of feet, so we want feet to cancel, where do feet need to be in our fraction? The bottom, so it would cancel with feet on the top. So we're going to choose this one. So we're going to multiply by 12 inches over 1 foot, right? If you do that, the feet cancel, On the top, we've got 14 2/3 times 12 inches. And on the bottom, we got 1 times 1, which is 1. Okay? How do we multiply 14 2/3 times 12? We need to change them both to improper fractions. How do we change 14 2/3 to an improper fraction? You do 3 times 14, which is 42, add 2, and you get 44 over 3, right? I don't know if I've told y'all, 44 was the name of my first pet. It was a black lab. I named him 44 because that was my favorite number. And I don't know why that was my favorite number. Okay, 12, we have to write it as a fraction, and that's 12 over 1 inches. How can we reduce this? You can cross cancel, right? So 3 goes in there 1 time, 3 goes in there 4 times. So we've got 44 times 4, which is 176 over 1 inches. All right, and we're back. Okay, so you see how we multiplied this and we got 14 2/3 feet is the same as 176 inches. Okay, so where we had 22 inches over 14 2/3 feet, we had to change both of those to inches, and we got this. Okay, so now the inches cancel, and you just reduce this fraction. What's something that goes into both of those? 2, and that would give us 11 over 88. What's something that goes into both of those? 11, and we get 1 over 8. So that is a 1/8 model of the Jeep that they used. Okay? So now we got a couple more vocabulary words. So we talked about ratio. What is a ratio? Fraction or a quotient that compares two numbers. Next, we're going to have a proportion. And it is just an equation, which means it has an equal sign, where one ratio is equal to another. Okay, so you have one ratio equal to another, a fraction equal to a fraction. And there are 4 places, and they are numbered in this order. This one's called the first position, this one is the second, this one is the third, and this one is the fourth. Okay? These positions have special names. 1 and 4 are called the extremes, which makes sense. Extreme means on the far, so if you had 1, 2, and 3, 1, 2, 3, and 4, extremes would be the ones on the end, 1 and 4. The 2 in the middle are called the means, because means is the average, it's the middle. So these 2 are called the extremes, and these 2 are called the means. And that's going to come in handy later, not so much in this chapter, but later. Okay? So let's say you had a proportion, and I'm going to give them all variables. So let's say you had A over B equals C over D. Which 2 variables would be called the means? B and C are the means, A and D are the extremes. Okay? Well, what if we wanted to simplify this proportion so that it had no fractions? What's the way to get rid of fractions in an equation? In any equation, if you wanted to get rid of the fractions. No. I mean, that would work, but what if we want to get rid of decimals too? You multiply the entire equation by the common denominator. And if you do that, it kills the denominator, gets rid of your fractions. Now, it doesn't have to be the least common denominator. That helps because it gets you smaller numbers, but it can be any common denominator. So what's an easy way to get a common denominator between B and D? Let's say B was 2 and D was 6. Common denominator would be 12, right? It's not the lowest one, but it is one. You can always get a denominator by just multiplying them, right? So a common denominator for this would be B times D, right? So what I'm going to do is multiply both sides of the equation times B times D. Okay? Well, we'd have to put that over 1, and we can cancel any top with any bottom. So what would cancel over here on the left? The B's would cancel, and what would you be left with? The top would be what? You just multiply the top, so it would be D times A, or AD, over 1, which you don't have to write. Correct? So that got rid of the fraction over there. What would happen over here? The D's would cancel, and what would it simplify to be? BC. Okay. Usually you put them in alphabetical order if you have more than one variable. So this is an equivalent expression to the original with no fractions in it. Well, look at what it really is saying. What are A and D in the original equation?
A and D
are the extremes. What are B and C? The means. So the product of the extremes is equal to the product of the means. Or another way of saying that is the cross products, which is another way of saying cross multiply, of a proportion are equal. Some other books, yours doesn't, list this as saying the product of the means is equal to the product of what? Product of the means is equal to product of the extremes. Okay? So you can use this to solve proportions. Okay, so let's give you an example. So, is this a proportion? Yes, why? It is two fractions, two ratios that are equal. And that's the definition of a proportion. So, to solve this, we can set the product of the means equal to the product of the extremes, or the cross products are equal. Now, I like to keep my variables on the left and anything else on the right. So I would do this product on the left. Now, you can do either way. But I would say 8 times 3x minus 1 is 4 times 7. You could say 4 times 7 equals 8 times 3x minus 1 as well. Oh, shoot. Okay. There we go. All right. So how do we simplify this? What do we do to the left side? How do we simplify? Distribute. 8 times 3x is 24x minus 8 times 1 is 8 equals 4 times 7 is 28. Then what? Add the 8 to both sides and we get 24x equals 36. Then what? Divide both sides by 24 and we get x equals 36 over 24. Now how does that reduce? What goes into both of those? 4 is one of them, so that would be 4 goes into there 9 times, over 4 goes into there 6 times. 3 goes into both of those, 3 over 2. Okay? Now in an algebra problem, or even geometry, as long as it's not a word problem, improper fractions are fine and actually preferred. So that would be your answer. Now, if this were a word problem and it wanted to know how many feet, you wouldn't say 3 over 2. You'd need to say 1.5 or 1. You need to change it back. But for this, it's that. Now, how could we check our answer? Plug that back in and see if it's true. So see if 3x minus 1 over 4 equals 7 over 8 when x equals 3 halves. So that would be 3 times 3 halves minus 1 over 4. Does that equal 7 over 8? Now, we're not going to cross multiply because we don't. You can only cross multiply if you know they're equal, right? We don't know that they are, so we're not going to cross multiply. We just need to simplify this side. So what is 3 times 3 halves? 3 times 3 over 2. Right, because you put the 3 over 1, and you would get 9 over 2 minus 1 over 4. Does that equal 7 over 8? Now, this is called a compound fraction. It's a fraction with more than one fraction bar, okay? So what you need to do, the way you reduce a compound fraction is you look at the top and you look at the bottom and you find a common denominator of all the denominators in the top and all the denominators in the bottom. Well, what's the only denominator in the top? 2. Denominator's bottom, okay? What's the denominator in the bottom? There isn't one, right? Because there's no fraction in the bottom. So how we can simplify this is to multiply top and bottom by the common denominator, which is 2. Now, we were just talking about, can we multiply a fraction by 2 over 2? What is 2 over 2? 1. Can you multiply something by 1 and not change its value? Yes. So we can do that without having to multiply the right by 2 over 2. Okay? If we just multiplied the left by 2, we would have to multiply the right by 2. But if you're multiplying by 1, you don't need to do anything to the other side. Does that make sense? Okay, so this we need to distribute. What's 2 times 9 over 2? Which is 9 minus 2 times 1 is 2 over 2 times 4 is 8. Does that equal 7 over 8? Yes, literally it is 7 over 8. So it works. Okay? All right, so now let's do, I'm going to show you one more thing about how to use these in kind of word problems, and then we're going to do 2 examples, and that's it, okay? So what if I told you 2 numbers are in the ratio of 2 to 3. Their sum is 75. What is the larger number? Okay, now let's pause this problem, and let me show you something else, okay? So this is not this problem, but it's something you need to know to solve the other problem. So let's say that we have two numbers that I tell you, two numbers are in the ratio 3 to 4. So let's go through, what does that mean the smaller number has to be 3 and the larger number has to be 4? If I tell you two numbers have a ratio of 3 to 4, does it have to be 3 and 4? Have a ratio of 3 to 4? It could be. It could be the numbers 3 to 4, right? What is another set of numbers that would be in the ratio of 3 to 4? 6 to 8, right? What about 30 to 40, right? As long as it reduces to be 3 to 4, okay? It could also be 1.5 to 2. Is that y'all's bell? All right. Well, let me tell you one thing, and then that'll get you to the end of this. This, would you agree, is 3 times 1 over 4 times 1? Now, I'll write y'all a pass to class because this is really important. This is 3 times 2 over 4 times 2, right? This is 3 times 10 over 4 times 10. And this is 3 times 1/2 over 4 times 1/2. Y'all come in quietly. I need to finish up this one thing. So every one of these is 3 times some number over 4 times that same number, right? So if I give you two numbers are in the ratio of 3 to 4, you could write the smaller number as 3x and the larger number as 4x. Okay? Nate, could you actually close that door and just tell everybody to wait outside? So, here, if I tell you two numbers are in the ratio of 2 to 3, you could say the smaller number is 2x and the larger number is 3x. We just have to figure out what x is, right? So anytime in a word problem you're given a ratio, just put x's on it, because then it would reduce to be that ratio. So if their sum is 75, you just say 2x plus 3x is 75. So that's 5x equals 75, so x is 15, which means the smaller number is 30 and the larger number is 45. And that works, and that's it. Okay? All right. That is it.